Welcome back, ladies and gentlemen. My name is Dylan Hamilton from C.A.R. Entertainment, and we are moving on from cells. We're on the AS1 biology, tissues and organs. Guys, there's only 2 videos going to be under this side of AS1 biology, and then we're done. We're done with AS1 biology. Then have a wee break. Basically, we're going to be starting off with the Ileum, and then we're going to do the leaf, and then we're done with AS1 biology. It'll be over, guys. Use these videos, come back to them in May, June. If this is your first time watching this in May, June, congratulations. Welcome to the channel. Click the subscribe button down below, get us likes, make sure you get these videos all around the place. We do want to help as many people as possible. But anyway, let's get straight in and start talking about the Ileum, because you could be actually draw something in your exam which may be the Ileum. So, what is a tissue? Let's just start off with talking about tissues and organs. Tissue is the amalgamation of cells all performing the same function, very critical there. Whereas an organ is a body part composed of several different tissues that are grouped together performing an overall function. A heart is the example of this. Now, the ileum works as a part of the digestive system, and the digestive system includes your mouth, the esophagus, the stomach, your pancreas, your liver, and your colon, which is otherwise known as your intestine. So, the ileum, it's a region of your small intestine, colon, where digestion is completed and most of the absorption occurs. So now there's numerous folds of the ileum which increase its surface area. These folds have numerous villi, is what we like to call them. They're called villi. And the lining possesses microvilli, which is a smaller version of villi, and this increases surface area for diffusion. Now this is very important. So, the histology of the ileum. Now you'll see on the left that is an EM version of it, so you'll see it's just labelled. You have your lumen, mucosa, submucosa, muscularis conterna, and your serosa and all, but we'll get into that there as we go. The main one you want to know for clarity is probably on the right. Now, as you'll see down the left hand side of your diagram on the right, you'll see it's broken down into subsections. That is what you will have to do if you have to draw it in the exam. You have to draw it in the way it basically shows. You might get this left diagram, you might be shown to draw that, and then you have to label it as on the right hand diagram the way it's shown. So you might have to do the arrow. This is a submucosa and all. You need to be able to identify that. So basically, as you go through, there's loads of things. You have your epithelial cells, your goblet cells, your intestinal glands, all that there, your villi, serosa, muscularis, submucosa, mucosa, all that there. But we'll get into that. So, the structure of the ileum, part 1. We're going to start off from the bottom going upwards, so we're going to talk about your serosa, which is the bottom part. This provides a very thin protective and supporting lining for your alimentary canal. So, pretty basic start off with your serosa. It's a thin protective and supporting lining for the canal. And then you move up to the muscularis externa, which has circular muscle and longitudinal muscle. Now, whenever your longitudinal muscle will contract, this makes the pendular movement of the gut. However, whenever your circular muscle contracts, you'll have local constriction, and this then push your foods along your gut by peristalsis. Then you have your submucosa, so just below the mucosa, you have your submucosa, and this is connective tissue, which has many blood vessels and lymphatic vessels. This is very crucial in transporting your absorbed food products. So, moving on to part 2, you'll see the wee diagram up there. It's basically just a very nice 2D image saying what's what. So you go actually from your submucosa to your muscularis mucosa before you actually get to the full mucosa. And the reason for this is that your muscularis mucosa is very important whenever you're for moving villi, which is present in the mucosa, which means it increases the contact with digested food. So without this here, the villi present in the mucosa wouldn't come in contact with the digested food. And this is because your muscularis mucosa is basically small strands of smooth muscle that extend from your main muscularis mucosa to your mucosa into each villus, and the contractions of these strands produce the characteristic wafting movement. Now then, your actual mucosa. This is the part that comes into contact with your food in the gut lumen. It's highly specialised with an increased surface area because of your villi and microvilli. Now, your mucosa has different parts to it, so we're going to start talking about the villus, which is just a plural term for villi. So, your columnar epithelial in your mucosa is a column-shaped cell that lines the intestine with free surfaces. These cells have microvilli which form a brush border. Now, glucose and amino acids will come into your epithelial cells by active transport, which then diffuse into the capillary network by facilitated diffusion. Lipids, however, will diffuse into the cells and then into lacteals, which goes all the way up through the centre, as you see in the diagram. You see lacteal just below brush border up there. So, we're now going to talk about your epithelium. Your epithelium consists of columnar cells, as we talked about columnar epithelium, and then goblet cells. Goblet cells are just cells that produce mucus, which lubricates your food and making the passage easier. This basically prevents damage to your intestinal wall by digestive enzymes, so it's quite important. Your surface remaining will be covered in microvilli. This forms your brush border that we just mentioned, and it will also increase the surface area of the ileum for maximum absorption. So if you ask the question, how is the ileum adapted for maximum absorption? Increased surface area for microvilli. Now finally we're going to talk about villi, crypts and pinocytosis. Again, it's in the mucosa, so your villi and crypts. The base of your villi, we'll go all the way back to this diagram once more, you'll see has the crypts of Lieberkühn, which are the very bottom parts of the villi. So as you see the white part coming around, going up and down, you'll see that the very bottom of that there, where it's quite pinkish, that is your crypts of Lieberkühn. So they secrete intestinal juice, which increase the volume of fluid in the gut. They also secrete enzymes, which are produced by Paneth cells, and the Paneth cells line the base of these crypts. Paneth cells will produce a new epithelial cell by mitosis, and they will have an antimicrobial function, which protects neighbouring actively dividing cells. And finally, pinocytosis. Now this is the absorption. It's a wee bit different in the mucosa than it is whenever you talk about cells. So pinocytosis in the mucosa is the absorption of extracellular fluids and antibiotics generated in very small vesicles. They're unspecific in the substances it transports, as we know, because the cell takes in surrounding fluids and all solutes will be present. I hope this video has made a lot more sense to you on the terms of the ileum. I've been Dylan from C.A.R Entertainment, and I'll see you next time.